Hey there, happy Wednesday. I wanted to go through a few systems that we call them special systems. Special because they might look a bit different than the ones that you have solved. And this will help you as you work through your Desmos today. So I have you doing this video first. Again, I did attach a note sheet that could be helpful. If you're able to print, please do so. If not, just grab a sheet of paper and go ahead and work right alongside us here. So to begin with, you might remember this first diagram, one solution, no solution, infinite many solutions. So far you have done some systems in which there has been exactly one solution written in XY coordinate point form. So today I want to introduce you to some different types, one being no solution. So two lines that when extended would never touch. Now, before spring break, we did a little bit of work with these lines, and you might remember that these lines are called parallel. And something important to these lines is that you're going to know that you have a set of parallel lines if their slopes are the same. So just by looking at these two lines, if their slopes are the same, I know that there is no solution. So you could write no solution or a zero with a little line through that. That is the symbol that says, hey, these lines will never cross. And then the last type of our special systems is something called infinitely many solutions. So here, where both lines are exactly the same, they have indefinitely many points, so we would actually give the symbol of infinity. So there is infinitely many solutions, so we would just use the infinity sign. Okay, so let's take a peek. I've got a couple problems. So this first one here, I've got a little bit bigger of a graph to help us out. But what I want you to notice is the system itself is a bit more complex. These are both written in standard form. So for us to graph them, you could do a couple of things. You could find their intercepts, x and y intercepts. That would be one option. Or another option is you could get the y alone and change them both into slope-intercept form. I think for today, I would like to practice that, getting the y alone and finding their slope and y-intercept. So I'm going to start with the first equation here on the left. I've got 2x. Oops, I better get my writing tool here. So I'm going to use purple. So I've got 2x plus 3y, which equals 6. So in order to get our y alone, we've got to do a little bit of work. I'm going to subtract 2x on the left, subtract 2x on the right. My 2x's cancel. I've got 3y equals 6 minus 2x. So far, so good. Now, we still have one step. We've got to get that y alone. So to do that, this times 3, I'm going to divide by 3 on the left and divide each term by 3 on the right. So my final solution is going to look like this. Y equals 2 minus 2/3 x. So I see that my y-intercept is at 2, and my slope is going down 2, right 3, 2/3. So if I graph that, so I'm going to start at 2. There's my y-intersection. And my slope is going to be down 2, 1, 2, right 3, 1, 2, 3. Down 2, left 3, down 2, left 3. So here is a picture of that line. Okay, now I'm going to use a different color. I'm going to use this blue. So my second equation, I have 6x plus 9y equals 18. Again, in order to find my slope and y-intercept, I've got to get the y alone. So the first thing I'm going to do is I'm going to subtract 6x on the left, and I'm going to subtract 6x on the right. So when I do that, my 6x's cancel. That's what I was hoping for. And I've got 9y, which equals 18 minus 6x. Now, divide by 9, divide by 9, divide by 9. So when I simplify here, 9 divided by 9 is 1y. I've got y equals 18 divided by 9 is 2 minus 6/9 x. Well, 6/9 can be reduced. 2 over 3x. Now, you might notice that the y-intercept is 2, and the slope is down 2, right 3, down 2, right 3, down 2, right 3. So when I graph these, they are the identical equation. So every single point they have in common, there's every single solution together. So here, the solution to this system would be infinity. There's infinite number of solutions for this system. They are completely the same line, and that happens. Moving on to our second example. If you go to the bottom of your page, here I have, it says solve the system of equations by graphing. So here, notice I've got y equals, so that's good because I can find my slope and my y-intercept a bit quicker that way. So I'm going to just jump right into solving here. I'm going to start graphing, and I'll do purple with the first line. So my y-intercept is -1, so I'm going to find -1. And I'm going to apply my slope. I've got a slope of 2, so that's rise 2, run 1, rise 2, run 1, rise 2, run 1. I can rewind, fall to left 1 if I want to see points that are going to the left. So here's a picture of my purple line, first one. My second line, I'm going to switch over here, and I'm going to make this kind of an orange color. I have a y-intercept down here of +2. So here's +2. But check out my slope. It is also 2. Rise 2 over 1. Rise 2 over 1. Down 2, left 1, down 2, left 1. What do you notice? When you graph them, they are completely parallel. This system has a set of lines which will always be parallel because their slopes are the same. So we would answer the solution to this system is no solution. And when you start working with these, your eyes will catch that pretty quickly. Notice here, you can kind of see immediately in the beginning as you're looking at they're both in y equals format. 2x, 2x, slope the same. I had a hunch that they would be parallel, and when I graph that out, it proves it. Okay, so these are just a couple of special systems. And again, once you start working with them, you practice them, they will pop up a bit more, and you'll kind of have a little hunch that they're coming. So I hope that helps you with your Desmos today. Have a great day.